All right, for the very last set of notes for today, we are going to take a look at what collision theory is. So, collision theory basically tells us how and why do reactions actually occur. So, the main part of collision theory, and I'm going to break this down for you guys, but collision theory essentially states that atoms, ions, molecules, they can react to form products when they collide. If the particles have enough kinetic energy, so remember that is the energy of motion, and if they collide with the correct orientation. So that's the overall definition of collision theory, is that they have to hit each other, they have to have enough energy, and they have to do it at the right orientation, means like the right angle or the right parts of the molecule have to hit one another. So what I want to do is I want to go down, I want to break this down part by part. So the first part of collision theory says that the atoms or molecules have to actually gain energy. So, for particles to collide with one another, they actually have to gain the energy first. So, the minimum energy that they have to gain is called the activation energy. And sometimes that's written as E sub A, as an energy of activation. And that should make sense because if it's the minimum energy, it's the energy needed to activate the reaction or what's needed for everything to start. So the reason we talk about this in this unit is because that energy typically comes from heat, and that's why we're going to talk about it right now. So the second part of this is once they have enough energy, part two, the particles need to actually collide with one another. Now, they can't just hit one another. When they collide, they have to collide at the correct orientation. So I want you guys to think about Velcro for a second. For Velcro, there's two parts that stick together. If you turn one of them backwards and it's upside down, no matter how many times you hit the Velcro together, it's not going to stick if it's not the correct sides of it. So that's how molecules are too, that not only do they have to hit each other, but they have to hit each other at the right spot. It would be like trying to put a magnet on something that's magnetic. Doesn't matter how bad you shove it at the board, or the wall or whatever, if the surface is not magnetic, it doesn't collide at the correct orientation, it's never going to work. So the third part of this says the particles, once they collide at the correct orientation, they have that energy, they hit each other the right way, then the particles are in a state known as the transition state. So the transition state is this weird in-between state where they're no longer reactants. They've collided with one another, but they haven't yet broken apart yet into the products. So it's just this weird in between where they're no longer reactants and they haven't formed products yet. Um, a lot of times we also call that the activated complex. And then the very last part of this is the particles rearrange themselves to form the products. So if we take a look at these reactions on the side over here, you can see that part one says the minimum energy that they have to gain is called activation energy. So over here we start as reactants, and basically what we're looking at here is the reactants are gaining the energy to be able to collide with one another and get up to that activated complex. Now, once they form that activated complex, so again, part one is they're gaining the energy they need, they have to hit each other at the right spot. Once they do that, they create that activated complex. Um, then, once they create the activated complex, then they release energy and they release that energy and then they form the products. Um, the same thing happens, the energy changes in reaction two, where it's starting off as reactants, they're gaining the energy and colliding with one another. They become an activated complex, and then they release energy as they form products. So even though these two graphs look a little bit different, it's the same overall process. Gain energy, hit each other at the right orientation, form that transition state, release energy to form products. So the difference between these two graphs is that this first graph up here, you can see that there is an overall loss of energy because it's releasing a lot more than it's gaining. So we know that this graph is exothermic. Now in this one over here, you can see that overall it gains energy. So it's gaining a lot more than it's releasing. So we know that this one is endothermic. And we're going to talk about those a little bit more on the next page. Make sure for the test on Tuesday that you guys are well aware of collision theory, the different parts of collision theory, and generally how it works. All right, I flipped to the very last page of your notes, and this talks about there are two ways that heat can flow. There's exothermic and there is endothermic. So in the first part up here, when we are talking about exothermic reactions, remember that exothermic is meaning that overall heat or energy is released. So releasing energy, the delta H, meaning the overall heat flow, is negative because this reaction is losing heat overall. So the reason we know that this is exothermic, remember exo meaning exit, is that even though all reactions have to gain a little bit of energy to actually get them started, the amount of energy that is released overall is much greater. So right here, you gain a small amount just to get the reaction started. Over here, you release a large amount and so overall, when we're looking at, saying that delta H is negative, that's what we're talking about, is that a little bit went in and a lot came out. So think about this as if somebody owed you money. If somebody owed you $5, so if someone walked up to me and gave me a $5 bill, I would be gaining a little bit of money. But if I owed someone else 20, yeah, I gained 5. But if I had to give away 20, overall, I'm still losing money. And that's kind of how exothermic reactions work, is that you may have gained a little, but overall you're losing more. So that's what we're looking at with these exothermic reactions. Now, endothermic is going to essentially be the opposite, where with endothermic, overall, we're absorbing energy. So delta H is going to be positive. That's going to be something like melting. It gets warmer. So if you take a look here, the activation energy in the beginning, you gain all this energy to get up to the activated complex. Then at the end, you're only losing a little bit to get to the products. So in the beginning, gain a large amount. At the end, though, you release a small amount. And so overall, when we're looking at this delta H being positive, we gained more than we got rid of. So if we use that money example again, let's think about that. If one of you owed me $20 and I owed someone else 5, I brought in 20. Yeah, I had to get rid of a little bit, but overall I still made $15. So when you're thinking about endothermic reactions, you gain so much more than you have to get rid of. So overall, you're gaining energy. But like I said in the page before this, it's important that you guys understand that both of them, you have to start off by gaining energy. Then in the second graph, you're gaining energy. Then you are releasing energy. And in the second graph, you are releasing energy. The difference between endothermic and exothermic is that with an exothermic reaction, you gain a little and release a lot. So overall, you're releasing. For endothermic, you gain a lot and release a little. So overall, you're gaining energy. All right, guys, that is the end of the note packet. For the rest of class, I need you to work silently by yourselves on your note packets. I'm sorry, on your homework packets. If you finish up your homework, you can go ahead and work on your final exam study guide. Remember that we have a test on Tuesday, so you need to make sure through the whole packet, we learned a lot in 2 days. So go back, make sure you know the vocab, make sure you know how to do the math, make sure you understand the differences between like exo and endothermic, and what is an activated complex, a transition state. You understand all of the different phase changes that we talked about. So all of that is going to be really important for the test on Tuesday. We're going to take about half the class to review and answer questions, but you guys need to make sure that you come to class with questions for that review so that 45 minutes in, we are ready to take the test.